So, welcome everybody. So, I'm very happy to be here, and I'm going to chair over the following two talks. So, first, I'm delighted to introduce Salvador Barberà, is a professor of economics at the Autonomous University of Barcelona, and is going to present about sequential voting and agenda manipulation. Salvador.
Is it working? Okay. Very happy to be here. Thank you to the organizers and to everyone for being here. As Sergio Soares, let me say, I'm going to present this joint paper with Anke Gerber from the University of Hamburg. As you will see, it's on a very classical topic, on voting theory. As Sergio Soares said, game theory has a number of applications, and on some of them especially close to real life. And I will not claim that voting is more important than auctions or matching, but I can claim that the interest on voting and in game theoretical aspects of voting has a much longer tradition. And I will provide you proof of that in a second. It's also been mentioned that Eric Maskin was here last week talking about manipulability of methods. I'm not going to contradict him today, but I'm going to look at a different way to manipulate mechanisms. And because of that, I will also go back to the issue whether or not simple majority is superior or just non-comparable with other forms of qualified majorities, which are sometimes required rather than simple majority to make final social decisions. So, like any researchers know, contradicting is not the problem, is maybe looking things at different perspectives, and that's what we're going to do today. So let me start by a proof that indeed game theoretic voting issues have been around for a while. This is part of a letter from Pliny the Younger in AD 105 to his mentor Afranius Dexter, in which he expresses his concern and doubts about whether he did or did not do a good job in the Senate when a case was presented. And the case was this one. The consul Afranius Dexter had been found dead. So it was not known whether he had killed himself or his servants were responsible. But in that case, it could have been that they had acted criminally or just followed the orders of his master. And the issue was what to do. If he had died, his servants should be freed without punishment. If they had followed his orders to help him die, they may have violated some moral law, but were not guilty of a big crime, they should give even a small punishment. If they had killed him, they should be put to death. And the Senate was divided roughly in three parts with equal opinions respecting one of these things. And he was fully aware that the way in which this question was presented would be decisive in terms of the outcome that would result. There was one way to present it in which they can vote for either of the three, and then obviously none of the three will get a majority, and then some internal coalition formation would go on. One way to, if not avoid that, to structure that voting method in a more systematic way would be to present the voters with binary decisions. First, they could decide on two options and then on the third one. For example, they could say, Are they guilty or not guilty? And if guilty, what punishment they deserve? Or they could say, should they be killed or not? And if not, what else do? No? Oh, no, that was the same one. Well, I could say, you can organize these things in the three different ways because of the order. And I will see formally how this is done. And we will also see that the order in which these options are presented is going to be very decisive in the final outcome. So, that's the topic we are going to cover. We are going to examine sequential voting rules in which at each instance individuals have to decide upon two possible ways of action. We are going to consider the strategic possibilities that is opens for a chair whose task, among others, is to decide on the order of vote. This has been studied thoroughly by the literature for the case where the decision is taken by simple majority. And we are going to introduce the possibility, in addition, that the decision whether to branch in one direction or the other of the voting system be made not necessarily by simple majority, but maybe by qualified majority. And we are going to examine in these cases what are the possibilities that the chairs find open to manipulate in that particular sense, not in the sense of misrepresenting their preferences, which was the direction in which Eric Maskin discussed yesterday and on which many of us, including me, have worked systematically, but on this different type of manipulation, the one that comes from the fact that you have control on the agenda, that you can decide on the order in which the decisions are taken, but not necessarily under simple majority, maybe also under other forms of majority. And that's what we are going to do, and we are going to do it for two particular types of ways in which the voting, the sequential voting, can be organized. And these are the two most used methods, as we shall see, that are actually heavily studied for the workings of parliaments. Let me show you the difference between the two methods we are talking about for the case where there are three possible alternatives. The first method that we'll call the amendment procedure, and I'm going to do it very simply for three alternatives, is the one where you establish an order, say A, B, C. Now you first confront the first and second in this order, A versus B, and then whichever is favored in the initial vote is then confronted. I don't know if I have a pointer here. No. Not the color. Well, okay. No. So, no. I'm using it. Don't worry. Okay, so you decide. No, don't touch. You decide between A and B, and then if B wins, you decide between B and C. If A wins, you decide between A and C. This is the amendment procedure. The other procedure is the successive procedure. Now you also have the order A, B, and C, but when confronting this decision, if A wins, it's already there. It's A. If A does not win, then you have to choose between B and C. And these two methods are different. In fact, the procedures that Plinius the Young discussed were more like the left, the one in your right, in which, you could decide, well, should we kill these people, yes or no? And if not, what kind of alternative do we follow, a light sentence or a strong one? Or we could say, well, should we, declare them guilty or not guilty, and if so, what else to do, etc. Now, This is also, by the way, the structure of for those of you who know what's going on in Catalonia, my country now, and in Spain, we have a referendum for November 7 that may or may not happen. So I'm talking about practical stuff. And the question is, may look funny to you, is, do you want Catalonia to be a state, yes or no? If you say no, that's A, that's it. If you say yes, then the question is, do you want this state to be independent, yes or no? And so you have three alternatives. You have no, yes, no, whatever this means, yes, yes, okay? So you see that both in the very distant past and in the very near future, these things are used, in fact. And they are used in many, many places. For example, they are used in the successive procedure in some form of another can be idealized as following these, as being followed in parliamentary practice in all these countries, and the amendment procedure in this other one. So the amendment procedure is more related to Anglo-Saxon tradition, the other is more to to continental European tradition, but both are heavily used. And, I'm a little bit worried to mention these things in front of Steve Brams, who knows so much about it. But as you will see, our contribution hopefully is one where what we depart is from majority voting, as I said. Okay, so here is the classical starting point for a lot of social choice theory, including Arrow's theorem, and is that when we have two alternatives, majority is a very amenable thing. No? Either you have a majority, you don't have a majority. You have a simple majority, you don't have a simple majority. You have a qualified majority, you don't have a qualified majority. No ambiguity. When you have more than three alternatives, it can be that according to whatever majority concern we are serving, it could well be that when confronted pairwise, A is socially preferred to B, but B is socially preferred to C, and C is socially preferred to A. The problem with that in theoretical terms is that then what seems to be the natural definition of what should be chosen, which is whatever is socially preferred should be chosen, then stops having meaning, because there is no such thing that is socially preferred to everything else. And this is the classical Condorcet paradox, on which much of game theory, game theoretical aspects, but also normative aspects of social choice procedures takes a starting point. But let's see a little bit more carefully what can happen in that case. Let's start by the first of the methods, by the amendment procedure. And let's look at this case where A is preferred to B, B is preferred to C, C is preferred to A. If all individuals vote sincerely, just for a moment, forget about the possibility of being strategic. So let's previous to game theory, so to speak. If you have an order A, B, C, you would first vote for A and B. A would win, then you go to A and C wins. So the sincere outcome would be C. But if the order of presentation had been BCA, then between B and C first, you would choose B, and then between B and A, you choose A. And with the third case, you would choose B. Okay. So the order would completely determine the outcome if people voted sincerely. Now, would people vote sincerely or not? That's another concern. People may realize that, if they vote for A, then they go to this disjunctive A and C, and the end result is C. So they could have said, okay, at the beginning of the voting, they can do what's called backward induction. No? They can say, okay, what's the consequence of the vote of A between A and C? The consequence of the vote between A and C is C. What's the consequence of the vote between B and C? It's B. So actually, when I am called to vote between A and B, I'm not going to consider that I'm voting between A and B. I'm voting between something that leads to C and something that leads to B. So if I prefer B to C, I'm going to vote for B, even if I may like better A. Because voting for A is not voting for A, it's voting for C. And so the sophisticated outcome, which is in terms of game theory, the backward induction equilibrium of this game, is no longer C, which would be the sincere outcome, but B. The problem is that with the other order, if we do the sophisticated reasoning, backward induction reasoning, now we would get C. And with the other order, we would get A. So regardless whether individuals are all sophisticated or not, the order matters. And what we are going to do in this, what we're doing in this paper is to consider that people are sophisticated. And so we're looking at the sophisticated equilibria of these votes where people look, forward and realize that the consequences of voting between A and B in the first case or between B and C in the second case are not the straightforward thing, but they are actually, like in one case, voting between C and B, in the other case, voting between A and C, and so on. This is even more important because being straightforward in the other procedure is not even a clear thing. We have said that individuals may prefer A to B or B to C or so on. But here, when you confront this other method, you see that you're asked between A and not A. But not A is either B or C. So what is to be straightforward? So let's go directly to the sophisticated analysis, and in the sophisticated analysis, we can see that the outcome in the first case, if you prefer, if the order is A, and then if not A, then B and C, the outcome will be, if I say not A, I'm going to get either B or C, but between B and C, I'm going to get A. I'm going to get B, so between A and B, I'm choosing A. And in the second case, it's a similar reasoning. I'm voting between B, and the winner of AC is C, so then between B and C, I vote for B, and so on. But the same phenomenon occurs. The order fully determines the outcome. I've done all this reasoning for the case of majority voting, and indeed, the case of majority voting is extremely well studied. There is a literature that I passed, but that is, I can go back to, if you wish, with full of authors that have fully satisfied all research concerns in this topic. Now, so this is the definition of the sophisticated outcome. Let me just point out the following. All that matters when analyzing these games, when there are not two alternatives, but any number of alternatives, then, is the social relation, whether A is better than B socially or not. And this can come from the use of some rules And the rules we are concentrating on is the rules that determine that X is socially better than Y if the number of individuals that prefer X to Y is greater than or equal to a certain number Q. When Q is half of the voters plus 1, that's simple majority. If it's larger, then this is qualified majority. If it's smaller, it's a less obvious type of rule, but you can also define it, and it would probably represent situations where a small active minority can put forward winning options. At any rate, notice that if we have an odd number of individuals, simple majority implies two important conditions on this social relation. One is completeness, meaning that either X will be preferred to Y or Y will be preferred to X, because one of the two will have a majority over the other for sure. Completeness. The other property is asymmetry. If I have a majority or X has a majority over Y, then Y does not have a majority over X. The social relation satisfying these two properties, completeness and asymmetry, constitute what are called tournaments. And a tournament is a mathematical object that has been subject to enormous amount of study and literature, where the main issue is that often a tournament does not necessarily have a clear idea of what is socially best, but then the tournament literature tries to analyze the different meanings in which we could qualify the idea of what is best for different applications. In our case, we are going to study things that you could call generalized tournaments or quasi-tournaments, because what we do is to realize that when you have, for example, a supermajority, it may well be that X does not have a supermajority with respect to Y, but Y does not have a supermajority over X either, in which case the social relation is no longer complete. You don't know which one is better than the other either way. If you have, but in that case it will be asymmetric. If definitely one has a supermajority over the other, it won't be the case that the reverse is true. So we will have asymmetry without completeness. The alternative is if the quota is very small, you may have this small majority to hold in one direction and also even in the other, so you always have completeness. But then you may miss asymmetry because you may have that both hold at the same time. So this is our contribution to this literature, is to analyze these things that are no longer tournaments and to ask questions that have a very traditional flavor. The question would be, under these cases, when are there possibilities to manipulate by choosing the order? And in particular, could we say whether amendment procedure is more or less manipulable than the other procedure? And for each one of them, could we say that the majority size makes or doesn't make things more manipulable in one case or in another? So I don't know how much time I have, but I should maybe skip.
20 minutes.
I have 20 minutes.
Oh, sorry, 24 minutes.
Okay. So let me show you a little bit how we would compute the sophisticated outcome for an agenda. If we use the order x1, x2 to xm, what would the amendment procedure do? It's a rather complicated calculation, but we can define it in an inductive way. You know, you could say, well, if there were only two alternatives, we will choose the second one if the second one dominates the first. Otherwise, we stick with the first one. So you see it gives a little advantage to the first one. In the case where they cannot be, in one you need full domination to go, in the other only weak. And this is, we break ties by determining the order. So the order determines many things, but in particular, the first comer has a slight advantage over the latecomer. Given that, then, what would be the outcome of the amendment procedure if we had defined what would be the outcome for a certain number, m-1 of alternatives, and we had already that, then what would be the outcome in the case of m alternatives? Well, we could be define it like that. Our comparison would involve that if we have to decide between x1 and x2, we look forward, and we know that if we go to x1, then we'll go to the sequence x1, x3, etc., because we have eliminated 2. If we keep x2, then we'll go to the sequence x2, x3, xm, because we have eliminated 1. These sequences are one amount less, so we know that we can compare them. And then we'll decide to go in between x1 and x2, we will decide to go for x1, or let me say, we will decide in the bottom line to go for x2 if the sequence O, x2, x3, xm gives us something that is socially preferred to the sequence x1, x3, xm, and vice versa. And for the successive procedure, the same type of technique can be used to define, but I will not spend much time on it. So let me advance that our idea of manipulation will be double, and I will come in a minute. One idea is, look, for certain preferences, I may find that the order doesn't matter. If the order doesn't matter, the chair cannot manipulate by the order. And that's the end of it. So we'll look for cases where this happens. When the order matters, the chair can choose. But then it becomes important to understand the latitude of the chair's choice. It's not the same to be able to obtain 2 alternatives only by changing the order of vote, than being able, for example, to choose any possible alternative, as it was in the case of 3 alternatives and the examples I gave you. So we're going to, in addition to this dichotomic decision whether you can at all affect by the order or not to, we are going to also go into the issue whether one procedure gives you larger opportunities for the chair or smaller ones, depending on the social preferences. Okay? So this is where we are heading to. But in order to head in that direction, it is first very important to be able to characterize, for a given problem, what would be the outcomes that one can reach by different possible orders of alternatives. Okay? So we shall denote by OAP the set of attainable alternatives under the amendment procedure given P. P would be the social relation, the one that tells us whether any alternative is or is not socially preferred to another. And here is the result. We say, as you see, we say, let P be complete or asymmetric. Because I said that under a small quota, you had completeness but not asymmetry. Under a large quota, you have the reverse. Only with simple majority, you have both. This is the case that has been thoroughly studied. We want to extend it to the other cases where only one of the 2 properties holds. And this is our motivation, is the use of these qualified majority rules. So let P be complete or asymmetric. And what we want to know is whether X can be attained by some order. And we're going to say, well, in order to know whether X can be attained by some order, it has to be that if we look at X and then at the set Y of X of those alternatives that dominate it, for any of these Y's, there should be a Z that dominates Y, but does not dominate X. So you could say that, you can think of X as the one that you want to come out. You can think of Y's as potential enemies of X that would win over X in a confrontation, in a direct confrontation. Then Z's are the enemies of Y, the ones that would eventually eliminate Z's. So the technique, as we advance, will be to say, well, X can come out even if it has enemies that could eliminate it. We can organize our vote in such a way that by the time that this comparison between X and Y comes out, the voter knows that it's not really a comparison between X and Y. It is a comparison between X and some Z that would have eliminated Y before. Okay? So that's the kind of contorted definition of X is attainable if for each Y that could dominate it, we have a Z that dominates the Y but not the X. And in addition, because the order is important, there exists a certain ordering of these Zs, let's say the friends, indirect friends of X, that would do the job, as we'll tell you. Okay? So this is a theorem, it's an if and only if. If X satisfies this thing, it may come out for some order, if not. So the idea of the proof I already gave you. Basically, the necessity is of the part of the proof is to say, look, if I have this, I need these enemies of Y because Y otherwise would win over X, and I need to use these things. I need them. The sufficiency is to say, if these conditions hold, here is the order I will follow in order to attain X. And look, for this, here we will follow different orders depending on whether the majority quota is high or low, or whether we have completeness or not. In one case, we'll put first all these Z's, which are the enemies of Y, in the late part of the sequence, then the Y's, then the X, and then all these things that are neither enemies that have not appeared in my definition. In the case of asymmetry, what you see we do is we put X first. But this is just how we determine the order. In the successive procedure, the ideas are very similar, but a little bit more complicated, because now we have to decide on the complete or the asymmetric case are not identical in statement, but very similar. So in one case, but it's always the same, we have an X, we have its potential enemies, and then we need Z's that kind of eliminate these potential enemies Y's. What we require from them in that case is a little bit different. If it's complete, we require downstairs what is written in black, ZPY. If it's asymmetric than what require what is in the first condition written in blue, not YPA, not YPZ. We do not longer require this additional condition that these things are not killed by X directly. And also, in terms of the orderings, we have things that are a little bit more complicated, but that I will not insist upon. But basically then, with these same ideas, necessity comes out because we need these alternatives that will eliminate the enemies of our candidate outcome before this candidate outcome is confronted, or rather, alternatives that will not be taken as such when the time of vote comes, because by looking forward, you realize that if you take an alternative path to X, you are going to end up worse. And the order of vote is similar as the one I said before. In one case, the X comes after the things that are a little bit on the side. In the other case, it comes first. But here, before, instead of having Ys and Zs explicitly stated, we talk of Ws because it is rather tricky, and we have to select an order of these Ws are both the X's, the Ys and the Zs, and we have to select a very delicate order in which to put them in order to finish. These are long proofs by induction, but that's our task to do, not today. So let me turn now to manipulability. When will it be that individuals cannot manipulate? When whatever the order is, the thing comes out. So it's very clear that if we have what we usually call a Condorcet winner in majority voting, it's one that is socially better than the others, then this one will come out no matter what. Okay? In this case, we have here, we have to be a little bit more delicate because we have to say that it's something that dominates all others, but since we do not have one of the two properties that hold in tournaments, we have to be explicitly saying that these alternatives are such that X dominates Y and no other Y dominates it, okay? Explicitly. Otherwise, it would be implied. So in that case, it is clear that if one of these things exists, then it will win at some point any other thing that it's confronted to and will be the end winner. The issue is, are there other more complicated situations in which I might get a single alternative by some choice of orders that even when there is no such Condorcet winner? And it took us a while because in some cases it's clear, but in others it's a little bit more delicate. But yes, indeed, there are no other cases. Okay? So the only way in which you won't manipulate is if there exists one of these animals. In all other cases, you will have sets. So that's our first result. Given that once we don't have this generalized Condorcet winner, there will be opportunities to manipulation. So our first condition could say, or our first conclusion would be, from this strict view of manipulability by order fixing, both procedures are equally manipulable in this dichotomic sense, yes or no. Are they equally manipulable in the sense that they give the same amount of flexibility to the chair? No. In that case, we can, let me skip this one, I can come later. This is the result. For every P asymmetric or complete, we have that the set of possible attainable outcomes under the amendment procedure is never larger than the set of attainable outcomes for the sequential procedure. No. And not the other way around. So there may be cases where the outcomes are the same, the set of outcomes that you can attain, but if there are cases where one is larger than the other in the set containment, it will be, the smaller one will be the one associated with the amendment procedure. And going back to these conditions, here we have put together the conditions. In blue, there are the conditions that we already described for the amendment procedure, and in blue for the sequential procedure, and in A for the amendment procedure in red. And an inspection of these conditions when putting them together will reveal, if we had more time, that the reason for our following theorem is that to become an outcome in the amendment procedure you have to satisfy more demanding requests. But the intuition is quite clear in the sense that, if you remember, in the amendment procedure, you have to beat everyone. In the other procedure, if you are first and win, you are done. So in that sense, it is less demanding. Okay, so this is our first conclusion when comparing this across these two procedures. I could go for this, but let me go to the other question. Is now let's look at the amendment procedure. Could I say under the amendment procedure that the choice of the quota makes a difference in terms of chair manipulability by choosing the order? Yes or no? If we only stick to the idea of one outcome non-manipulable, many outcomes manipulable, then I will not contradict Eric Maskin, although he was talking about another form of manipulation. And majority voting, like in many other situations, emerges as a special and especially favorable thing. In that case, it could maximize the number of profiles where there is no room for order manipulation. Okay? On the other hand, if we look at now, and the same is true, excuse me, and the same is true, no, I'm now, so this I don't think I have here. Yeah, that's what is here. No. That's the other thing. So the one I'm going to say. What I told you is a new result that was not included here. No? So what I told you is, if we look at the dichotomy, simple majority emerges in both cases as the case where there is less manipulability. But if we don't look at this dichotomy and we say, okay, let's look now, when you can you manipulate toward a larger set in one case than in the other, yes or no? Then we have that, in general, you cannot say. So it could be that a large quota, and things are not nested in general. It could be that with a large quota, you get a small set, and then with a slightly smaller quota, you get another set which is larger, and then you go back when you keep decreasing the quota, set that is smaller. So you cannot rank the majorities in terms of the size of the sets that they will provide to the chair as opportunities. You cannot rank them in general. You can only rank them in the particular case, not of the amendment procedure, but of the the sequential elimination procedure there, where in that case, for quotas that are larger than 1/2, then it is true that the larger quota provides more opportunities for manipulation. So in this restricted case of quotas between the simple majority and supermajority, in this case, yes, you can say that simple majority is, in that second procedure, provides less opportunities to manipulation than larger qualified majorities. But only in this case, not for small quotas, and not definitely in any case for the amendment procedure. So we have a lot of examples. Let me just say that it is been well known that 5, 2, 1, 0, 2. It's been well known that the amendment procedure will never give you Pareto-dominated alternatives, whereas the other procedure may provide in certain instances for the outcome to be even Pareto inferior. But so in that sense, and this was well known for the case of simple majority, and it is still true for the other cases. But the result goes beyond, because it's not only Pareto versus non-Pareto outcomes that makes the difference in the sizes of the sets. You can also get things that are not Pareto dominated, but enter one of the sets, but not the other. So basically, this is our conclusion. There are two types of possible classifications. One is a dichotomic one. For this one, we have rather sharp results that these things look very similar in terms of manipulability and eventually favor simple majority. In the case where you want to go further and not only compare whether it's manipulable at all or not, but you want to qualify it by the size of the manipulations, then the comparisons are much less deterministic, etc. So back to Plinius. What happened to Plinius? What happened to Plinius is that he was presented with a sequential voting. I've been reading this text that was brilliantly elaborated upon by Robin Farquharson in a master's dissertation in the 60s. A brilliant paper which became a book, Theory of Voting, that I wholeheartedly recommend to you. Beautiful pictures. Pre-game theory, And in my last reading, the guy argued that there was no reason to do this in sequence because sequences would generate advantages. And apparently he managed to get the three options to be on the table on an equal foot. And his concern at the end, when writing to his mentor, was, okay, I didn't get anything because then a coalition formed. And the outcome was the same, okay, as you would have expected from a proper sequential method. But of course, the coalitions that would form would be different, whereas in this, anyway. So I hope this was at least entertaining and a proof that some of the things that we now do in game theory, as we know from also other literature, have been thoughtfully discussed by our long time predecessors, maybe not in these words, but with equal wisdom or lack of wisdom thereof. Okay, thank you.
Thank you very much. Now we have a few minutes for questions, if there are any.
Hello, I'm a gradation graduating student from, some undergrad student from FGV at Economics. I actually, you made me curious about one thing about, what about if there's not perfect information on successive voting? That is, when someone wants to hedge their bets, voting for the one that will finish it, instead of risking getting one that they might not want.
I think this is an absolutely legitimate question. And you catch me in a situation where I am talking about a topic in which it is absolutely legitimate. Let me say you that most of my life and my work has been on strategy proofness. Strategy proofness is a different type of property in which we also examine strategic issues, but not relating to the order in which we vote, but relating to whether or not, when asked for our preferences, we do reveal them or not, which was, in fact, the kind of manipulation that Professor Maskin discussed, and on which I have invested most of my work. Now, in that other context, I'm not escaping your answer, I'm just giving a prolegomena. In that other literature, I insisted very much on strategy proofness, because strategy proofness means that telling the truth, revealing your preferences, is a dominant strategy. Now, why was I so interested in it? Because if you have dominant strategies, I should be ashamed of saying that in a game theory place, but I will say it, then you can escape game theory. Don't worry about it. I mean, you have a dominant strategy. What else? You know? So that's, for people like me who are only marginally game theorists, that's very safe. You know, you have a dominant strategy, you're happy. Of course, it is hard to get mechanisms with dominant strategies if you look for unrestricted domains, but there are many, many applications, including voting under single peak preferences, including matching models, including many other things, where it is possible to define strategy-proof mechanisms for those restricted domains which are induced by natural economic considerations. So my sympathy goes for strategy proofness because it does not require anyone to bother about game theory. Now, in this particular case, I happen to bother about game theory because our considerations were, in fact, if you think of it, these guys, I never said what was a good strategy for one of these chairs. I just said, you know, this is no longer a game theoretic problem either. I mean, the game theory was in the analysis of what was attainable. But once you know what is attainable, this guy is no longer facing a game. He's facing the uncertainty, maybe, of whether or not he or she will be the chair. But once he's the chair, it's a decision problem. I choose whatever is best out of this menu that is available to me by the orders. Okay? So in that context, I think my answer to your thing is that all the difficulty in resolving your difficulty lays in the careful analysis of these sequential choices according to some game theoretic concept that is either well established or to be established. No? So then what we have done is to take the view of complete information, right? If you don't want to do it with complete information, I wish you luck and strength. I think it's an excellent project, but then what you should do is to look at an alternative characterization of what behavior and consequences you could expect from the game that you would define under maybe partial information, no information at all. You may revert under certain assumptions to a position where you then can think that under complete lack of information, maybe a reasonable thing is to tell the truth after all, because these being monotonic mechanisms, either you lose or win, but on the average you'll probably win more than lose by telling the truth. But all this would have to be formalized, put into game theoretic terms, and then once the set of attainable equilibria would be, then you would revert back to what we have done. But I think it's an excellent question and a challenging project.
Okay, we may have like one more short question, if there is any.
What happened to the servants?
I think they were given a light sentence, but either Plinius was too worried about or maybe they have put to death, because he was very anguished in the letter. But I was anguished enough with the problem that I didn't finish the last lines in my last reading, and once know, but I do not know now. Sorry, but it's let me put it this way for people who are not necessarily theorists. It's such a thrill to understand that these people were so sophisticated and not only acted strategically but reflected on the strategical aspects, that I think that if you have spare time and go to a wonderful book that I can recommend, which is called, it's by Hurkens, and it's about the history of social choice. It's readings on early social choice. I have to tell you, that's for chapter 1. Chapter 2 are 2 papers, if I can call them so, two writings by Ramon Llull from Mallorca, philosopher, 12th century, early 13th century. In one of them, he describes very, very convincingly the Condorcet winner. In the other, he describes very convincingly the board account. Where does he apply it? To the choice of abbots and abbesses in monasteries. Does he speak about manipulation? No. Explicitly not. But he requires people to confess before going there, because their voting is going to reflect the will of God as to who will be. And this directly connects with what we know today about the Condorcet jury theorem, which is choosing the right guy or the right sentence. And in addition, for my absolute pleasure, he wrote one of these essays in Latin and the other in Catalan. So what else can I expect?
Thank you very much, Salvador.